Hello everyone. Today we will show you how to make a serial in serial out and serial in parallel out register. Okay. In the screen you can see this is the register circuit. Okay. And here the switch is our clock pulse. So this one is the clear input of the D flip-flops. Okay. And you can see here we have two 7474 IC in which each IC contain two D flip-flop. And you can see here I already connect all of the clears together, and this yellow one is our clear input. So in this IC we have active low clear. That means if we give 0, then the output will be all 0, right? So here you can see the above rail, this one is our positive +1 and this one is the 0, that means ground. So if I connect this yellow one to the ground, then output should be 0. You can see when I connect the yellow one to the 0, all of the output is 0. Okay, and now when the clear is 0, whatever we do in the circuit, the output will not change. Okay, now you can see I connect the white one. The white one is our input of the resistor. I will show you in the circuit diagram later. And here if I take out the yellow one, that means now in the clear input I didn't give the 0. So now connect this one to 1. As this is active low clear, if I give 1 to the clear input, then output will be normal, right? And here you can see this is our clock pulse, and the white one is 1. Now if I just click the clock pulse here, this switch, then the first LED should be turned on, right? You can see I just pressed 1 and the first LED is turned on. Okay, if I press the second time, then the next one should be on. You can see the next one is turned on, right? As the input is 1. So that means I just give 1 to the register, and that one is shifting to the right side, right? So the first LED is turned on, and now the second one. If I press the next time, then the third one should be turned on. You can see the third one is turned on, right? That means I already applied the 3 clock pulse and the input is shifted right side. Now I will press the another time. Then the blue one should be turned on. You can see the last one is also turned on, right? So you can see that if I just give the clock pulse by this switch, then the output is shifting from the first flip-flop to the last flip-flop. Okay, so here I show you the serial in parallel out register. Okay, by the way, serial in parallel out and serial in serial out, the circuit diagram is completely same. Okay, but for the serial in parallel out and the serial in serial out, the output will be different. That means in serial in serial out, there will be only one LED, the right side one, this one. Okay, but for the serial in parallel out, we will have the 4 LED. Why? As we have the 4 D flip-flop. Okay, so that means if I made the serial in parallel out, then that will also work as a serially serial out. Okay, so let's build the circuit. So first take out all of the wires from here. Okay, and then go to the iPad. First I will show you the circuit diagrams and the pin configuration of the 7474 IC. Okay, so here you can see this is our breadboard, and in the breadboard I connect two 7474 IC. This 7474 is the D flip-flop IC. Okay, I didn't take out this two, and here in the right side we have the LED circuit, where you can see I connect 1 kilo ohm with the each LED. Why? As it will limit the current such that the LED will not burn. Okay, and this one is a switch. I will use this switch for the clock pulse. Then I don't need to transfer the clock pulse from 0 to 1. If I just use this one, then this will work as a clock pulse. I will explain you this one also. Okay, here the clock pulse is a positive edge triggered for both the IC. Okay, and I will show you here the clear is an active low and preset is also active low. Okay, so let's go to the iPad. This one is the 7474 IC pin diagram. Okay, here you can see this one is the number pin 1. That means in the IC we should see this kind of U notch in the right side. Okay, as I told you, if we saw the notch, then the bottom of the notch, this pin will be number 1, and then it will be go like U shape. Okay, so this will be number 1 pin, number 7 pin, number 8 pin, and number 14 pin. In general, all the 14 pin IC, the 14 and the pin 7 should be the power supply. That means the pin 7 will be the ground and pin 14 will be the VCC. For the IC, we need to use 5 volt as a power supply. As if you check the data sheet of the 7474 IC, then you can see the input range should be 4.5 volt to 5.5 volt. Okay, so if we give this IC 6 volt or beyond 6 volt, then this IC will be burned. Okay, this will be one thing, and there will be don't give this one 5 volt and this one ground. If you give this kind of thing, then this IC will be burned. Okay, so keep remember, always keep the VCC 5 volt at the pin 14. Okay, here you can see we have two D flip flop. This is the flip flop 1 and this is the flip flop 2. Okay, so for the flip flop 1, you can see here the number 1 pin is the clear, right? And this clear is connected to the D flip flop with a bubble. That means this is a active low clear, right? In my previous video, I already told you active low and active high, present and clear. In that video, I told you that what is active low, what is active high. Active low means if I give 0 at this clear input, then the output will be always 0, as I already show you in the circuit. Okay. Here the preset is also, you can see the number 4 pin is the preset pin. Okay, and number 4 pin is connected with the flip flop with a bubble. That means this is also a active low preset. Okay, understood? We can see the same thing for the number 2 flip flop. Number 2 flip flop, the pin number 11 is the, sorry, in the number 2 flip flop, the pin number 13 is the clear. Okay, and also you can see the pin number 10 is the clear, and both clear and preset is the active low. Okay, so you already understand the pin number 1, pin number 4, 13 and pin number 10. Okay, now for the flip flop, we all know that we need to give the clock pulse. Here you can see we have the positive edge triggered clock pulse, right? Why? You can see there is no bubble, and as you can see this triangle, that means this is a edge triggered flip flop, not level triggered flip flop. Okay, in general we always use the edge triggered flip flop. Here also for the flip flop 2, we have the same kind of clock pulse, positive edge triggered clock pulse connected in the number 11. Okay, so the clock pulse is connected with the number 3 and number 11. As we need to make the register, as we all know that the register is a synchronous sequential circuit, right? That means these two flip flops should be work together. So what we need to do? We need to connect the clock pulse together at number 11 and number 3. That means we need to short the number 3 and number 11 pin. Okay. Then you can see here the number 2 is the input of the D flip flop. Okay. And here number 12 is the input of the D flip flop, the second one. Okay. So we will give the input on the number 2. Okay. Here Q is the output connected in the number 5 pin, and here also you can see the number 9 is the output. Okay, that means we will not use the number 8 pin, as number 8 pin is our Q bar. To make the register, we don't need the Q bar. Okay, so we will not use the Q bar pin in this practical. Okay, understood? So this is the pin configuration of our 7474 IC. When you go for the examination, you should remember this pin configuration. Okay. Now let's build the circuit diagram of the serial in parallel out register. We need to make 4-bit serial in parallel out register, right? So this is the D1, Q1, D2, Q2, D3, Q3, D4, Q4. Okay, and there will be clock pulse, positive edge. This clock pulse should be connected together, and this one is our clock pulse. Okay, and here this is a negative, sorry, this is the active low clear, right? So all the clear terminal will connect with the bubble. This one is our clear. All the clear should be short. And then we also need to connect the preset. So this one will be our preset, okay? And D1 will be our input and Q4 will be output for SISO. But when we need to do the serial in parallel out, at that time, what we need to do? We need to take the output from each of the flip-flop output. So that one will be like this. I will take out from here and connect a resistor to limit the current, and then I will connect a LED. Okay, it will be same for all. Okay, here I take 1K resistor. You need to take the resistor at least 330 ohm. Why 330 ohm? As you can see, the output should be 5 volt, right? For a for a LED, the current should be less than 15 milliampere. If I calculate the resistance, then it will be 5 by 15, it will be 330 ohm. Okay. As I don't have the 330 ohm, that's why I just use the 1 kilo ohm just to play safe. Okay. So this is our serial in parallel out resistor. Okay. Now I need to give the pin number in this circuit. So first you can see I will give the pin number in the green color. This should be the pin 2. Okay. As you can see here, I already show you. This is the 2 pin and this is the input of the first flip flop. Okay. And Q1 is of number 5. That means this will be number 5. Okay. D2 is what? D2 will be in the pin 12. Okay. Always cross check that one. Otherwise, this is a little practical. And if any of the input and output is different or any of the jumper when you place in the other place, okay, the whole circuit will be NG. Okay. So first I will attach the clock pulse. So the clock pulse should be number 3 and there the clock pulse is number 11. Okay. So for the second one also it will be same 3 and 11. This will be number 2 and number 5. As we have two flip-flop in one IC, that means this side will be one IC and this side will be other IC. And all the pin will be symmetrical in this two part. Okay. Now the clear. The clear you can see the number 1 is the clear for the first one and number 13 for the second one. Okay. Now we need to get the preset. Preset is number 4 for the first one and preset is number 10 for the second one. Okay. I think no problem. So here you can see this is connected, right? Oh, Q2. Q2 is which one? Q2 is number 9. So this one also number 9. Okay. So here you can see we already connect all of the pin with this circuit diagram, right? So that means now we just need to use the jumper wire and make this circuit in the breadboard. Then the output will be okay. Okay. One more thing I need to tell you that about the clock pulse. So first make this one, then I will tell you about the clock pulse. In this one, this is a D flip-flop IC and this one is a TTL IC, okay? That means the gates of these flip-flops are made of TTL, transistor logic, okay? That means if any of the input is open, that means that one will be considered as a 1. Understood? In last video, one of the student comment this one, why the output is 1 in though we didn't give any input, okay? As this was made with the TTL logic. In the TTL logic, if we didn't give any input in any pin, then that will work as a 1. Okay, that's why in general, here is the active low clear, active low precedent clear. Okay, that means if we didn't give anything on the clear, then this circuit will be working fine. Why? Giving nothing, that means this is already give 1 and 1 active low, doesn't work. So that's why we need to give 0 to this one to make it work. Okay, understood? I will use this one to make the clock pulse. Okay, so let's build the circuit first. Here you can see this two is our flip-flop IC, D flip-flop IC. 7474 and 7474. Both are identical IC. Okay. Now we need to use this one for the first two flip-flop, and this one will be the last two flip-flop. Okay. So now just see the circuit diagram and place the wires. Okay. First we need to connect the power supply. So to connect the power supply, I will use this red wire for the power supply, and this will be connected to the VCC, right? You can see connected to the VCC, the first one, and to do the same thing. Okay, so both the flip-flop IC connected with the VCC. Now I need to connect the ground. Okay, so now we already give the ground and the VCC. The first one is the D1 will be our input. That means the input will be number 2 pin, and for the input we will use the white cable. Okay, so this is the number 2. We can see here number 2 I connected the D1. And for the clock clear input, you can see number 1 and number 13 pin, right? So number 1 and number 13 should be shorted. So number 1 is this one, number 1, I connect the blue one, and 14 is this one, the red one, and 13 will be this pin. Okay, so 1 and 13 is short for the first one. I have to do the same thing for the second one. Okay, so the clear is shorted. Now I have to short the clock pulse. For the clock pulse, the pin number is number 3 and 11. That means this is number 1, the blue one, white one is the number 2, and for the clock, this will be number 3. So I use the black one. Number 3, second will be 11, right? So this one is the red one is the number 14, 13. So this one will be number 11. Okay, so let's do the same thing with the second flip-flop. The number 3 and number 11. Okay, done. Now I have to connect both the flip-flop together, right? That means both the IC together. So need to short the clock and clear. For the clear, I use the blue one. So use the blue one and connect it from the 13 to number 1. That means now all the clear is connected together. Okay, so you can see here the first one is number 1, and then it goes to number 13. Okay, and from 13 it goes to number 1 again, and from 1 it goes to number 13 again for the second IC. Okay, and then we need to use the clock pulse. That means number 3, right? So here I have to take out from number 11 this one and connect it to the number 3. Okay, here you can see the number 3 is connected together. Okay, so the clock pulse is also connected with the both the flip-flop. So first you can see for the clock, the black wire, this one is our clock, number 3 pin, and it connected with the number 11 pin. And from number 11 pin, we goes to the right side flip-flop, that means right side IC, number 3 pin and number 3 to number 11. So all the clock is connected together and all the clear is connected together. Okay, now I need to connect the clear input. For the clear input, I will use a green one. For the clear, I can see here 4 and 10. So number 4 is the clear. So this one is the number 4, and this will be connected with the 10. For the IC, this is number 8, okay, 9 and number 10. Number 10 is empty till now, okay. So I need to connect it just side of the clock pulse, okay, and take another one from that one, okay, and just use the same thing for the right side flip flop, number 4, and to connect with the number 10. Okay, so now I need to connect both the IC together. Then, so this one is the number 4, and it will connect it to number 10 of the first IC. Okay, no problem. And this one is the green one is our preset, white one is our input. So the blue one should be clear, so connected to the number 1. So this blue one is our clear, white one is the input, green one is the preset, and I need to connect the clock path, that means the black wire. So take a black wire. The black wire should be the clock path, that will be number 3 pin. Okay, so the black one is our clock path. Okay, no problem. So I already connected this kind of all of the wires. Now I need to care about the output of each flip flop, and that one need to connect with the input of the another one. Okay, so the first one, the output I will take with the yellow one. The first output is number 5, right? So here you can see the first one is the output number 5, and from the number 5 it will goes to the 12. That means the another input of the D flip flop. So number 5 pin is this one. This is number 5, and this will connect it with the number 12 pin, that is the D2. Okay, so number 12 is which one? In the middle, so it is little bit difficult to connect. Okay, so I connected with the, you can see here, this is the number 12. Okay, so from the number 12 we need to take out the output to the first LED, right? So this is the number 12, this yellow one, and it should connect with the LED circuit. Okay, I connect the first LED. Okay, now need to ground the LED also. First ground this LED with the ground pin. No problem. Done the first one. Then we need to connect the number 9 is the output of the second flip flop with the number 2 pin. Okay, so the number 9. This is number 8. Okay, and the number 9 is the right side. Number 9 is the left side of this pin. So this one is our little bit complicated. This one, as we here we have too many wires. This is the number 9. Okay, it should be connected with the number 2, that means the number 2 of our second IC. Okay, so from the number 9 I need to connect the output to the second LED. Okay, done. Now I'm connecting number 5 with the D4. D4 should be the number 12, right? 12. So number 5 connect with the number 12. So number 5, that means this one is our number 5, and this will be connected with the number 12. Okay, connected. And from number 12 or 5 we need to connect the output. So number 5, and it will goes to the output with the third LED. Okay. Now the last one. The last output will be number 9, and that one will be the output for the SISO. Okay. So number 9 is this one. This is the number 8 pin, and this one is the number 9 pin, and it will be connected with the blue LED. Okay. Now we need to ground the LEDs. Okay. So our circuit diagram is done. Now we need to use the clock path. So let's go to the iPad. I already told you that in any input of this IC, if I didn't give anything, that means that is the 1. Okay. And for the 0, I need to connect it to the ground terminal. Okay. So how I will make a clock pulse? You can see here. I will connect a switch from the ground. Okay. And then this will I will tell as a clock pulse. Okay. Here you can see we have the positive edge trigger, right? But here I connect it with the 0. Why? Let's see. First, just think like this. The switch is open. Okay. If the switch is open, that means this clock is not connected with anything, right? That means now the clock is 1. Okay. Now I press the switch. If I press the switch, that means this one clock is connected with the ground. Okay. At that time, the clock pulse should be 0. Okay. So I just press and hold this one, then this will be goes to 0 like this. No problem. Now, if I just release this switch from 1 to 0, then what you can see? Then you can see here the clock pulse will jump from 0 to 1. And at that time, you can see that the output will shifted. Why? This will be that time positive edge clock pulse. Understand the operation? Okay. First, if this switch is turned off, okay, at that time there is no connection between clock and ground. That means the clock pulse is 1. As I already told you, if there is nothing in the input, then that is always 1. So it will be 1. Okay. Now I just press the switch. When I press the switch, at that time this ground will connect with the clock pulse. That means the clock will goes to 0. No problem. And then when I just lift up the switch, at that time what will happen? This will again open circuit. That means the clock will be 1. So it goes to 1, right? And this one we can get the positive edge clock pulse. Understood? Now here I already connected a switch in the breadboard. So in the circuit I already told you the green one is all clear. That is the number 1 pin, right? Number 1 pin is the clear green one. Number 2 pin is the white, that is the input. Okay. And the black one is our clock pulse, and the preset is the green one, right? No problem. So connect the clock pulse, that means connect the black wire with this switch. Okay. And I will connect this switch to the ground. Okay. Now let's give the input. 1 and this one is our 0. Oh, here I use the white one. So just change it to green LED. Sorry, the blue LED. Here I use the blue LED. Just this one will be our SISO output. That's why I just take another color. So here you can see at starting there is no input, right? Still the output is all 1. Why? I already told you this is a TTL. That's why the output will be 1. Okay. Now I already told you that the clear is the blue one, right? The blue one is the clear input. That means if I connect it to the number 0 terminal, then all the output should be 0, as this is the active low clear, right? Let's see. You can see when I connect it, all the output is 0. Okay. Now if I just take out, you can see here nothing happened, right? Why? I already made all the output is clear 0. Okay. This white one is our input, right? And this one I didn't connect with anything. That means neither 0 or 1, right? But if I press the clock pulse, you can see that the 1 will be shifted. I didn't give anything, any input. Still, there will be some shifting. You can see here, I just press and release. You can see the output is 1. Why? I told you that this is a TTL logic, right? That means if you didn't give anything, then the logic you will consider it as a 1. Okay? So, if you want to give 1, then you don't need to connect it to the 1 terminal. Okay? You just take out, then that will consider as a 1. Okay? Now, if I connect it to the 0, you can see if I press, then light will shift it to the right side and this red LED will be turned off. Why the LED is turned off? As I give the input 0. Right? Now, if I want to give input 1, then just take out. Then what will happen if I press the clock pulse? If I press the clock pulse, the third LED will be turned on and the second one will be turned off and the first one will be turned on, right? Clear? Okay. Now I will show you the clear and preset operation again. So our clear is the blue one. So just press the blue one. You can see the output is all 0, right? And now I will show you the preset operation. For the preset operation, you can see the green wire is not connected with 1 or 0, right? That means this circuit will think that the preset is now 1. Okay, this is the preset one. This one is not connected with 0 or 1. That means the circuit will assume that currently the preset is 1. That's why you can see all the LED is not turned on as this is active low preset, right? If I connect this one to the 0, then all the output should be 1, right? You can see all the output is 1. Okay, so I think you already understand the working function of the clear, right? Just use this one to the 0, then all clear. Okay, now the working of the preset, the green one, use this one to 0. You can see all is turned on. Okay, and I already told you how this clock pulse is working. Just I show you in the iPad. Okay, and the input of the flip flop, that means this white one. Okay, if I need to give input 1, then I don't need to connect this one to anything. But if I want to give the input to 0, then connect this one like this and just press this one. You can see it just goes to the first flip flop. Okay, and again connect this one. And now if I press this one again, third, and again press this one, fourth. Okay, so you can see the shifting of the lights. Understood? Okay. And now if you want to check the SISO, just take out this first 3 LED and the output will be the last one. But for the SISO, it's very difficult to understand that this is working as you cannot see the 0 or 1 or on or off. Okay, it will be very difficult. You need to understand very carefully, then only you can understand that the SISO resistor is working. SIPO, serial in parallel out, is very easy to understand as you can see the LED is turned on and it will be shifting from left to right. Okay, so that's all about the serial in, serial out and serial in parallel out register. Okay, in our next video I will show you the another register, that is the another shift register, that is the parallel in serial out. At that one I need to use a multiplexer. Okay, that is a little bit more complicated, but what we will do, we will use the same circuit, okay, this one, but we will add a extra gates. So I will use these wires, I will not take out this one, just modify this one to make the serial in parallel, to make the parallel in serial out register. Okay, so that's all for this video. See you in the next one. Thanks for your time. Please do share this concept with your friends. And if you like this video, please press the like button. It is really means a lot for me. Bye bye.